So it's a take-home quiz from pre-cal. Just want to run through each problem. So if you turn your quiz in online, it was graded in Canvas, and I put in the comments the numbers that you got wrong. So then you can watch this video and find out, kind of hopefully figure out what you did wrong. Okay, so number one, sketch the graph of f of x. So we know that this thing crosses at -2 because of that, and 1 because of that. So put a dot there, we dot there. We also know that this is a 5th degree polynomial. 5th degree, which means, and it's a positive leading coefficient, which means it's going to be negative infinity on the left and positive infinity on the right. And then this x-intercept has a multiplicity of 3. So since we're coming from negative infinity, we're going to come up and basically we'll just kind of go flat and then keep going up. I don't know how far to go up. That wasn't something I was looking at. But I also know here that this is a multiplicity of 2, so when you come down, you should ricochet off of this. It looks kind of like a parabola and going up like that. This should not curve in, it should be keep going up. So that's number one. Something should look something like that. Number two, it says divide these. You could use regular long division or you could use synthetic division. I'm going to do long division for the first one, synthetic for the second one. So long division, you have 3x plus 2 divided into 3x to the third plus 5x squared plus 8x plus 7. So you ask yourself what times 3x equals 3x to the third, and that would be x squared. Then you multiply x squared on both of those, so that would be 3x cubed plus 2x squared. And then you subtract here. 3x cubed minus 3x cubed is 0. 5x squared minus 7x squared is negative 2x squared. Bring the 8x down. I ask myself, what times 3? That was a 2, wasn't it? My bad. So 5 minus 2 would actually be 3. So I ask myself, what times 3x equals 3x squared? That would be negative x. This is negative 3. Negative x times 3x would be negative 3x squared. And negative x times 2 would be negative 2x. And then I subtract that. And that would give me 0, of course. And 8x plus 2x would be 10x. All right. Bring the 7 down. Okay. I just realized I made a mistake. Go back up here, erase all this, erase this. Could start the video over, but it's probably good for you to see me make mistakes. That wouldn't have been a negative 3, that would have been a positive 3, because we got 5x squared minus 2x squared, which would just be positive 3x squared. Okay, so now, what times 3x equals 3x squared? That would be positive x, and that would give me 3x squared. X times 2 is 2x. Subtract that, and we get 0. 8x minus 2x would be 6x. Bring the 7 down. What times 3x equals 6x? That would be plus 2. 2 times 3x is 6x. 2 times 2 is 4. Subtract that again, and we get 3. So the answer to this would be x squared. So that would be x squared plus x plus 2. And then the way we write the remainder is we put the remainder, which is 3, over the divisor. Oops. 3x plus 2. So that would be the answer. Now this one, I'll handle this one a little bit quicker. I'm going to just use synthetic division on this one. So put 3 in the box because you put the root that goes with that factor. Put 2, -3, -5, -12. 2. 3 times 2 is 6. 6 plus -3 is 3. 3 times 3 is 9. 9 plus -5 is 4. 3 times 4 is 12, and we get 0. So that means we have a remainder of 0. And it also means that the answer is 2x squared plus 3x plus 4. And since there's no remainder, we don't need to put anything else out there. Okay, so that's number 2. I'm going to erase this real quick because I want to make room for other stuff. So hopefully you noticed on 3 and 4 they're the same exact function. You know, the two a's are the same, the b's are the same. So really you just sort of do one set of math, one bit of work, and then of course the answers will be different because this says find all zeros, that says find all, or write in factored form. So those answers will look differently. So zeros are numbers that make the equation equal to 0. So zeros can be imaginary or real. They're not like x-intercepts. If in this quiz, I didn't ask you to find x-intercepts because I could have had maybe problem 5 with the two same function and ask you that, and then that would be possibly a different answer than this one. But this just asks you to find the zeros, so we just got to find all the zeros. Now, because this is the 4th degree, we'd expect to find 4. This is the 5th degree, we expect to find 5. So if you're counting real and imaginary zeros, they'll always be the same number as the power, unless we have one that has a multiplicity. So like if 1 0 has a multiplicity of 2, then that'll take the place of one of those zeros, of course. Okay, so let's go to work on this. So the idea here is you would plug this into your calculator and see if you can get some easy, obvious x-intercepts that would be zeros. And I did that and found out that 1 is a possible 1. So I put a 3, a 6, a 3, a 24, and a -36. So just taking those numbers, bring down the 3. 3 times 1 is 3. 3 plus 6 is 9. 1 times 9 is 9. 9 plus 3 is 12. 1 times 12 is 12. 12 plus 24 is 36. And 1 times 36 is 36. And I get 0. Good, that's what I thought. The second one, if I remember right, was -3. And again, you can get that by looking at your calculator. -3 times 3 is -9. And that would be 0. -3 times 0 is 0. 0 plus 12 is 12. -3 times 12 is -36. And of course, that's 0 again. So that means that 1 and -3 are zeros. And there's 2 more zeros in here. Now, of course, this means 3x squared plus 12. If we set that equal to 0, we get x squared equal to -4, which means my other 2 zeros are 2i and -2i. That's what happens when I take the derivative of -4. I'm sorry, the square root of -4. That's a plus. Okay. And we do something similar to that with this next one, the question 3a. But before I do that, I'm going to hop down here and say, since we have the roots there, we know that this is going to be, in factored form, would be x minus 1, x plus 3, and then this is going to be x squared plus 4, because that's what produces those two things. And remember, there's an extra factor of 3, so I'll just put that 3 out front. Okay. All right. So we're going to do something similar with this, run through synthetic division. I think it was 2, -2, and 4, -4, I don't remember, but you get that from looking at the calculator. So, but notice here it's x to the 5th, x to the 4th, and there's no x cubed. So when you run this through synthetic division, you do a 1, a 6, a 0, a -40, a -16, and a 64. And like I said, we got a -2 here. So that'd be 1, -2, 4, -8, -8, 16. That would be what? -24. That would be 48. 48 minus 16 would be 32. And -64, which would be 0. And then I think 2 is also an option. So you go 1 times 2 is 2, that would be 6. 2 times 6 is 12, that would be 4. 2 times 4 is 8, that would be -16. 2 times -16 is -32. And that would be 0. So far it's all working, and I think the last one was, is it 4 or -4? I think it's -4. So that'd be 1. 1 times -4 is -4. That'd be 2, -8, -4, and 16. Yep. Okay. So that means my roots are -2, 2, -4, and there's 2 more hidden in there. And I might as well do this while I'm at it. That means that this is going to be f of x, written in factored form would be f of x equals x plus 2 because of that, x minus 2 because of that, and x plus 4 because of that. And this leftover bit here, x squared plus 2x minus 4. We write the unfactorable quadratic there because it doesn't, that's as far as we can factor it. So that'd be the right answer for 4b. For 4a, we still got to find 2 more x-intercepts here. We do that by throwing this into the quadratic formula. So we take a is 1, b is 2, and c is -4. So that would be -2 plus or minus the square root of 4 minus 4 times 1 is 4 times -4. So that'd be positive 16 in here, all over 2a, which would be 2. So then that's going to be -2 plus or minus the square root of 20 over 2. And that would be -2 plus or minus. Now, the square root of 20 is equal to the square root of 4 times the square root of 5. And of course, the square root of 4 is 2. So that's how you simplify that. That'd be 2 rad 5 down there and 2 there. And notice 2 is a factor of both terms in the top. So you can actually simplify this to -1 plus or minus the square root of 5. So that's what I put up here. Be -1 plus the square root of 5 and -1 minus the square root of 5. Okay. So there's 3 and 4. Number 5 says write the equation of polynomial with leading coefficient 3. So remember, leading coefficient can be taken care of just by multiplying by the right thing. And that's like a vertical stretch factor on the outside. So I can just start off by saying y equals 3 times something. Has a degree 4. We'll come back and check on that later with x-intercepts at -2 and 1. So that'd be x plus 2 and x minus 1. That would give me the right x-intercepts. But it says they both have a multiplicity of 2, which means I need a squared up there. And now we'll come back and check, does this polynomial I just wrote have a degree 4? And yep, I've got an x times x times x times x. So I did it. All done. This one says write an equation of the polynomial which goes through the following points. So the fact that it goes through these 3 points, those are all x-intercepts. So that's easy to incorporate into the equation. That would be x plus 2 because of the first one, x plus 1 because of the first one, and x minus 5. Okay? And now the question is, does it go through the point 0, 10, which is a y-intercept? So in other words, if I was to plug 0 in to all these x's, would I get 10? Let's try it. That would give me 2 times 1 times -5. And almost, I get a -10. So once again, I can save things by putting the little stretch factor out here. So what do I need to put out front to get the right answer when I plug in 0? Because this says when I plug in 0, I should get 10. Right now, when I plug in 0, I'm getting -10. So let's put a little negative out front. That way, they'd put a little negative right here, and that would change it to a positive 10. Perfect. Okay? And then finally, number 7, it says, it tells you 1 plus I is a 0, and you got to find the other zeros. So you can run 1 plus I through synthetic division. I think I've done a video of this already, but let's run through it again. So that'd be 1 plus I, and that'd be negative 1 plus I, because you add the two real components together. And when you multiply 1 plus I times negative 1 plus I, you get negative 2, so that'd be negative 3. And again, if you're not sure how to do that, it's just like FOIL kind of, 1 plus I times negative 1 plus I. Got to do 1 times negative 1, 1 times I times that, I times that. So that'd give you negative 1, and plus I and minus I would be 0, and then plus I squared. But I squared is negative 1, so that's where the negative 2 comes from. So then we get a negative 3 minus 3i, and those add together to give me 3 minus 3i. And once again, if you multiply those out like that, you get a positive 6, gives me 0. And then the other thing you have to remember is that conjugate or imaginary roots come in pairs. So since 1 plus I is a root, 1 minus I would also have to be a root. So I get a 1 down there. What that times that would be 1 minus I, and that gives me 0, which gives me 0, which gives me negative 3. Negative 3 times that is negative 3 plus 3i, which of course is 0. So I'm left with x squared minus 3. And of course, x squared minus 3, if I set that equals 0, I'll find the other roots. So that would be x squared equals 3, which means x equals plus or minus the square root of 3. So find the other roots. So 1 plus I is one of them. 1 minus I is another one, and rad 3 is another one, and negative rad 3 is another one. So that's the answer we'd be looking for there. And that is the take-home quiz. Let me know if you have any questions. Thank you very much.